Think about the last time you were genuinely not stressed. Not relaxed in the way that comes after a glass of wine or a good workout. Actually not stressed. No background hum of unfinished tasks. No low-grade anxiety about money, relationships, health, or the future. Just physiologically calm. For most people reading this, that memory is difficult to locate. Not because stress is inevitable, but because most people have been living in a state of chronic, low-grade physiological activation for so long that they have forgotten what the baseline feels like and have stopped noticing the damage accumulating beneath the surface. Here is what nobody tells you about chronic stress. The danger is not the acute stress response. The acute stress response, the burst of cortisol and adrenaline that sharpens your focus, accelerates your heart rate, and mobilizes your muscles for action, is one of the most elegant and effective survival mechanisms in biology. It evolved to keep you alive in moments of genuine danger. The problem is not that it activates. The problem is that it never fully turns off. Researchers at Carnegie Mellon University, the Max Planck Institute for Human Cognitive and Brain Sciences, and the Laboratory of Neuroendocrinology at Rockefeller University have spent decades documenting what happens to the human body when the stress response that evolved to last minutes runs continuously for months and years. The findings span every organ system in the body: the heart, the brain, the immune system, the gut, the reproductive system, the telomeres at the ends of your chromosomes. Chronic stress is not a psychological state with physical side effects. It is a full-body biological event with a documented, measurable, organ-by-organ damage profile. Today, I am going to walk you through that damage profile, system by system. Because most people living under chronic stress have no idea what is happening inside their body while they power through, and that ignorance is costing them years. Before we go through the specific organ damage, you need to understand the biological mechanism that makes chronic stress damaging. Because acute stress and chronic stress are not the same phenomenon at different intensities. They are qualitatively different biological events. The stress response begins in the amygdala, the brain's threat detection center. When the amygdala identifies a threat, it activates the hypothalamus, which triggers two simultaneous cascades. The first is the sympathoadrenal response. The hypothalamus signals the adrenal medulla to release adrenaline and noradrenaline into the bloodstream within seconds, producing the immediate heart rate increase, blood pressure elevation, and muscle tension of acute stress. The second is the HPA axis. The hypothalamus releases corticotropin-releasing hormone, which triggers the pituitary to release ACTH, which triggers the adrenal cortex to release cortisol. This second cascade takes minutes rather than seconds, but produces effects that last hours. In acute stress, both cascades activate, serve their purpose, and deactivate when the threat passes. The parasympathetic nervous system restores baseline. Cortisol levels return to the normal diurnal rhythm. The body resets. In chronic stress, the HPA axis never fully deactivates. Cortisol levels remain persistently elevated above the normal baseline, not at the dramatic spike levels of acute stress, but at a sustained low to moderate elevation that the body was never designed to maintain. And this sustained elevation is what drives the organ damage. Because cortisol, at acute levels, is protective. At chronic levels, the same hormone becomes systemically destructive. A 2012 study published in the Proceedings of the National Academy of Sciences found that chronic psychological stress produced measurable dysregulation of the HPA axis in over 80% of subjects, with cortisol patterns showing flattened diurnal variation. The normal sharp morning peak and evening trough was replaced by a flatter, chronically elevated pattern that persisted regardless of whether acute stressors were present on any given day. The HPA axis had lost its sensitivity. The biological emergency system had become the new normal. The brain is the first organ to show structural consequences of chronic stress, and the findings from neuroimaging research are among the most striking in the entire stress literature. The hippocampus expresses the highest density of glucocorticoid receptors of any brain region. In acute stress, cortisol binding enhances memory consolidation of threat-relevant information. In chronic stress, sustained cortisol suppresses BDNF, promotes glutamate excitotoxicity, damaging hippocampal dendrites, and over months produces measurable hippocampal volume loss. A 2012 meta-analysis in neuropsychopharmacology found individuals with chronic stress-related disorders showed an average hippocampal volume reduction of approximately 8% compared to non-stressed controls. 8% less hippocampal tissue means measurably impaired memory, impaired fear extinction, and impaired spatial processing. The prefrontal cortex is simultaneously impaired. Sustained glucocorticoid exposure reduces dendritic complexity. The branches through which neurons communicate become shorter and less elaborate. A 2009 study in the Journal of Neuroscience confirmed chronic stress reduced prefrontal dendritic arborization, with subsequent human imaging studies showing reduced prefrontal gray matter density. The result is impaired impulse control, reduced emotional regulation, and diminished executive function. The amygdala responds in the opposite direction. Glucocorticoids increase dendritic complexity in the amygdala, making it larger and more reactive, a hair-trigger threat detection system, amplifying emotional reactivity. Chronic stress is simultaneously shrinking the brain regions that regulate emotion and enlarging the region that generates it. The cardiovascular consequences of chronic stress are among the most clinically significant and most directly linked to mortality risk. Cortisol raises blood pressure by enhancing vascular sensitivity to norepinephrine, promotes sodium retention, increasing blood volume, and mobilizes free fatty acids. A 2017 study in The Lancet, following over 400,000 participants, found that psychological distress was associated with significantly increased risk of heart disease and stroke, with a risk elevation comparable to smoking 5 cigarettes per day. Chronic sympathetic activation drives cardiac remodeling. The heart muscle thickens in response to sustained elevated demand, reducing flexibility and efficiency of contraction. A 2019 study in the Journal of the American College of Cardiology found individuals with the highest chronic stress burden showed significantly greater left ventricular hypertrophy. Cortisol also reduces endothelial nitric oxide synthase activity. Chronic stress is not just raising blood pressure. It is accelerating the biological aging of the vascular system. The immune system is disrupted by chronic stress through a paradox that took researchers decades to fully document. Acute stress enhances immune function. The initial cortisol surge mobilizes natural killer cells and primes the immune system for tissue damage that might follow physical threat. Chronic stress produces the opposite. Sustained cortisol suppresses lymphocyte production, inhibits natural killer cell activity. A landmark 1991 study by Sheldon Cohen at Carnegie Mellon deliberately exposed 394 healthy volunteers to 5 different respiratory viruses. Individuals with higher stress scores were significantly more likely to develop clinical illness, not just feel worse, but actually become infected. A stressor lasting more than 1 month produced more immune disruption than an acutely intense but brief one. Your immune system is more damaged by the grinding, low-level stress of daily modern life. Your immune system is more damaged by the grinding, low-level stress of daily modern life than by the sharp, acute stressors that feel more alarming. The gut is profoundly affected by chronic stress through the gut-brain axis, the bidirectional communication network connecting the enteric nervous system to the central nervous system through the vagus nerve, the HPA axis, and the immune system. Cortisol increases intestinal permeability. Tight junctions between intestinal epithelial cells loosen under sustained glucocorticoid exposure, allowing bacterial lipopolysaccharide to cross into systemic circulation. This drives systemic inflammation and further activates the HPA axis. Chronic stress also disrupts gut motility. Cortisol and sympathetic activation slow gastric emptying and alter intestinal contractions. A 2019 meta-analysis in the American Journal of Gastroenterology found psychological stress was the strongest predictor of IBS symptom severity, exceeding dietary factors and sleep disruption. The cellular aging dimension of chronic stress is perhaps the most profound long-term consequence, linking every other mechanism into a unified biological story. Telomeres, the protective caps on chromosome ends that shorten with each cell division, are directly affected by chronic stress. Cortisol reduces telomerase activity. Oxidative stress from chronic sympathetic activation causes direct telomere DNA damage. And inflammatory cytokines elevated in chronic stress accelerate shortening per division. Alyssa Eppel at UCSF published findings in 2004 that transformed how science understands stress and aging. Mothers caring for chronically ill children had telomeres equivalent to women 10 years older, 10 years of biological aging from caregiving stress. The most stressed women showed telomere lengths and telomerase activity consistent with early cellular senescence. This finding has since been replicated across dozens of populations in stress paradigms. Work stress, relationship stress, financial stress, trauma history all produce measurable telomere shortening, and shorter telomeres predict higher incidence of cardiovascular disease, metabolic disease, immune dysfunction, and cancer. The same conditions whose risk is elevated by chronic stress. Here is what I want you to carry out of this video. Chronic stress is not a psychological experience with physical side effects. It is a full-body biological event that is simultaneously shrinking your hippocampus, enlarging your amygdala, reducing prefrontal executive function, remodeling your heart, stiffening your arteries, suppressing your immune system, disrupting your gut barrier, and shortening the cellular aging clocks in every tissue. The damage is silent. It does not announce itself. It accumulates under the surface of what feels like simply managing a demanding life, and it is not inevitable. The interventions with the strongest evidence, consistent aerobic exercise, adequate sleep, social connection, mindfulness-based stress reduction, all work through the same mechanism, reducing HPA axis activation, restoring cortisol diurnal rhythm, increasing vagal tone, and allowing the biological systems that chronic stress is suppressing to recover. The stress feels manageable. The organ damage is not. And the research makes clear that the distinction between managing stress psychologically and addressing its biological consequences requires recovery. What is your chronic stressor right now? The thing that is always there in the background. Drop it in the comments. You do not have to be specific, just acknowledge it. I read every single one. Subscribe to the channel because next week we are going into the specific interventions that the research shows actually move the biological needle on chronic stress. Not manage it, reverse it. And I will see you in the next video.